Hi, this is Andy. So in our last video, we talked about kind of the goals and objectives. What are we trying to accomplish with ESParaSite? And really what it boils down to is we want to get more information about what's going on in the environment of the printer. We want to put that into an easy to read, easy to follow format, and then be able to give you the ability to log that over time, because it will likely tell you some very important data about the printer, about your prints. So let's take a moment and talk about the sensors that are going to be inside ESParaSite. The first sensor we have is the DHT12 temperature and humidity sensor. It is a fairly slow I2C sensor, but it will work for our purposes. This will live inside of the print chamber and give us a continuous readout of temperature and humidity inside of the chamber. Now, when shopping for my DHT12 sensors, I found this sensor. It's the AM2320. It's often listed alongside the DHT12 sensors. This sensor is not supported as I've not been able to get mine to work. I don't know whether I have bad sensors, a bad library, or another issue, but at this time it is not supported. The next sensor we're going to talk about is the BME280 temperature, pressure, and humidity sensor. We're going to use this for the room or ambient temperature measurements, and it's going to live in a small 3D printed case on the outside of the printer. It's very important that you get the BME as in Echo 280 and not the BMP as in Papa 280 sensor, as they look very much alike. The next sensor on our list is the SI1145 light sensor. This sensor will live inside of the light path where it does not cast a shadow on the screen. However, its entire purpose is to measure the UV light coming out of the LED and see if that diminishes over time, as well as allow us to see if the printer is on simply by measuring whether the light is on or off. It comes in a couple of form factors like this, and then here on my breadboard for ESParaSite, a round, much smaller sensor about the size of a dime. So now we move on to our final sensor, the MLX90614 non-contact infrared temperature sensor. This sensor is particularly interesting because it will provide us with two very key data points that relate to the longevity of the components inside of a printer. The first is the LED heatsink. This will be mounted very near the LED heatsink, and it will be able to give us a temperature reading on that. If an LED is run for too hot, then it will decrease the life and the corresponding light output. The second data point we're going to gather from this is the LCD screen temperature. Being a non-contact sensor, we can measure from a distance, and it's going to provide us a very important data point, as we believe from what we've seen in the field that around 42 to 45 degrees Celsius, the screens start to fail. So our next module is not as much a sensor, but it is kind of the heart of the ESParaSite. This is the DS3231 real-time clock module. It has a real-time clock chip and an EEPROM chip that we use to hold some of the key settings and life counters of the device. Now, a real-time clock chip is interesting because most people don't realize computers don't think in time like us humans do. They only think in cycles. So it's impossible to get a really accurate reading over time from a computer on time. A chip like this allows us to talk in seconds, minutes, hours, and days. The interesting thing about it is it's also battery backed up. What that means is that we can turn the computer power or the printer power off for a few days, weeks, months, or years, and it will still maintain the time for us. Now, this particular one uses a lithium rechargeable battery. It's a LIR2032 style battery, but it is called an LIR2032 battery because this particular unit has a charger built into it. Now, the little brother of this device is called the DS LIR1321 real-time clock. This should also be a drop-in replacement for the 3231. It's a little bit of a smaller board, and to the best of my knowledge, it may have a charging ability, but it's not advertised on my board, so I don't know if those components exist, and mine came with a LIR2032 battery. Now, the interesting thing about this is the reason it's smaller than the DS1321 is because it has an external crystal. Moving right along, let's talk about the workhorses of the ESParaSite system. These are the data collector boards. They're based on the ESP8266 chip, and they come in a few different form factors. From left to right, you'll see the NodeMCU, the WeMos D1, and the ESP01S form. Now on your Photon mainboard or your Chi2-based mainboard, there's a Wi-Fi port. The ESP01 plugs directly into that. However, you will need to run additional wires over to the port from a NodeMCU, and wiring diagrams have been provided on the GitHub to help you do that. It's important to note, however, that even though the ESP01S comes in a 1 megabyte and a 512 kilobyte model, eventually the functionality of ESParaSite will exceed the capabilities of these boards, and you'll want something like the NodeMCU or the WeMos D1 Mini. So to bring it to a close, I want to talk about a few additional parts that may come in handy. The first is some 10 kilo ohm resistors. These are going to act as pull-up resistors. Basically what they do is you can put them at the end of a long signal run and it'll help stabilize the signal. Now these aren't necessarily required, as most of the sensors already have them built in, but I found that sometimes they help and sometimes they don't, so just keep them handy. The second thing we're going to want to have is some 28-4 cable. I believe the cable I've got here is a microphone cable. It is a 4-core or 4-conductor wire with a drain wire. Now the drain wire is kind of important in noisy environments, but I'm going to recommend you have one anyway. Basically, it won't be connected at the first sensor in line, and it'll only have a connection at the very end, at the very motherboard. And so what that helps do is it drains any noise that gets into the wire out into the actual system ground, rather than having it come along the wires. Like I said, I picked this up at Amazon in about a 1 meter roll. The last thing we've got here is just a couple of things that I find come in handy. You've got your small 4-inch thin wire ties. You have some self-adhesive mounting tabs for both wire ties and for circuit boards, and then some heat shrink tubing. Hi, this is Andy back again. So in our last video we talked about what did we talk about? Oh yeah. And so that's what I came up with it.